Alright, so today we're looking at solving systems. So the ones we're going to do today in class are the word problems so that I can guide you through it. On the back, you have some systems that I'm going to ask you to try for homework. Now, those are not word problems. Those are the kind that we're going to use technology to help us find the solutions to. So I'm going to show you how to do it on the graphing calculator here in class. You guys all should have access to a graphing calculator, and if not, use the Desmos app on your phone. Okay, number one, if a 34 feet of fencing is used to enclose a rectangular area of 72 square feet, find the dimensions of the area. So we have two things here. We have the length around the courtyard, the fencing, so that's perimeter. So the first thing is perimeter. The perimeter equals 34 feet. The second thing we have is the space inside. Space inside is area, and the area is 72 square feet. So when we do this in terms of the two dimensions that we do not know, they are x and y. So perimeter is 2x plus 2y, and that equals 34. Area is length times width, which is x times y, and that equals 72. And then we have a system we can solve. So when you guys started solving systems, we solved them several different ways. One way was substitution. Now substitution would work well for this one, because if we solve this for y, we get 72 over x. And if we plug that back in here, we get 2x plus 2 times 72 over x is equal to 34. So this one would not be hard to solve algebraically. And this is the exact thing we did at the very end of last semester. This is a rational function. So we have 2x plus 144 over x equals 34. Now what is the restricted value for x? What can x not equal? 0. Well, that makes sense. We can't have a dimension that's 0. Otherwise we wouldn't have an area here. Okay, so we know that. Now the next thing we would do would be to multiply through by the common denominator. There's only one denominator. So the common denominator is just x. So when we do that here, we get 2x squared. When we multiply x times this, what happens to the x's?
It goes away.
They go away. All right, so we have a quadratic. What do we have to set a quadratic equation equal to be able to solve it?
0.
0. So we're going to move that 34 over. So we get 2x squared minus 34x plus 144 equals 0. There's a couple different things we could do to solve at this point.
Quadratic formula.
We could use the quadratic formula. We could simplify this equation because you see what number divides out of all of those? 2. So we could divide both sides by 2, couldn't we? So we'd get x squared minus 17x plus 72 equals 0. Now, in this form, it's really easy for me to factor. What can I multiply to get positive 72 that I can add to get negative 17?
9 and 8.
Yeah, very good. So x is either 8 or 9. Well, if x is 8, y is 9. And if x is 9, y is 8. So 8 and 9 are my dimensions. So the dimensions are 8 feet by 9 feet.
We know how to do this? Did we already do this?
We've done parts of this. We haven't done this all together. So you guys have solved systems using substitution. You guys have solved rational equations. And you guys have solved quadratic equations. But this problem had all three together. You haven't done all three together. But that's how they fit together. Okay, number 2 is a little easier mathematically. It says a person is walking a straight line and a dog is running in the shape of a parabola. Well, that's a silly word problem. I never watch my dog running in the living room going, oh, that's a parabola. No. But how many times will the two collide? Let's talk about what that could be, though. If somebody's walking in a straight line and then a dog is running in a parabola, do they have to intersect? No, right here, these two would not intersect. It could touch just once if it was tangent, couldn't it? Just one little boom. Or they could intersect twice. Okay? So this is actually a very good problem to start using our technology on. So if we want to see how many times they actually cross, then we would solve this system. We would put this in for y1 and plug this in for y2 and see what happens. How many of you actually brought your calculators today? Oh, about half. Okay, I'll take it. So let me show you how this will look on the calculator since some of you have them. If you ever are sitting at home and you don't have your calculator, just use Desmos on your phone, guys. Desmos is the best online. I actually have the app on my phone because Desmos is easier to use than our graphing calculators. Yes. Okay. So let's take a look at these two equations on the graphing calculators. And if you have yours, you may go ahead and pull that out. If you don't, you just pay attention.
They touch twice.
You've already got it. You beat me to it. Okay, so in y1, we'll enter the first equation, which is 2x plus 3. And in y2, we'll enter our second equation, which is x squared plus 3x plus 2. And then we can see there's our line, and here comes our parabola. And we can certainly tell they do intersect twice. They intersect here and here. So how would we use our calculators to actually find those intersections? If they're not perfect, if they don't cross at the zeros, how would we find them? What we do, okay, second trace, and then what do we choose?
Minimum or maximum?
5 for intersection. If we want to see where they intersect, we would choose choice 5. So this is new. Now, this says first curve. Well, our first curve is not actually a curve, it's a line. But if we want to know where the intersection is, like if I want to find this intersection here, I would put my cursor on one of the functions and get close to that intersection. Not on it, but close to it. And then it jumps to the second one. So I would get close to that intersection and hit enter. And then I hit enter for guess. And it tells me what the intersection is. So this intersection
0.61.
So there's one intersection. So now to find the other intersection, we'd go through the same process, but we just put our cursor down close to this intersection. So we'd do second trace, and then choice 5, and we would arrow down to where we're close to that other intersection. And then hit enter, and then it jumps to the other curve, and then we hit enter because it's already close. And then you always just hit enter for guess. And then here's our other intersection. And that is a very nice thing about technology. It keeps us from solving this algebraically, which we could. It would be a quadratic function that when we set equal to 0, gives us one that does not factor, so we'd have to use the quadratic formula. And if we use the quadratic formula, this is what we get. But using technology is nicer. So let's work this same problem now, but we're going to work it using Desmos. So you can see how much nicer Desmos is. All right, so our first equation was y equals 2x plus 3. And our second equation was y equals x squared plus 3x plus 2. Now, this is so much nicer because all I have to do is put the cursor over the point and it tells me. Put it over the intersection point and it tells me. So this one gives us the solution just quicker. And we can see it. Oops. All right, so those are two methods of using technology, either your graphing calculator or Desmos, to solve nonlinear systems. And that's a great way to solve things that are not linear. So anytime we have a quadratic or a cubic or a rational or any of that involved, it's nice and easy to do it using technology. Questions about number 2? Okay. All right, number 3. All right. How many of you already know the answer without having to set up any system? Yeah. And does a 5-inch screen exist on a television? Maybe your phone.
Yeah, my phone.
Maybe your phone. Okay. But let's take a look at this. This is the Pythagorean triple, isn't it? This is a 3, 4, 5. 3, 4, 5. And what is 3 times 4? 12. So there's no need to set up a system on this one. The dimensions are, the length and width are 4 by 3. 4 inch by 3 inch. All right. Let's take a look at number 4. Find the lengths of a right triangle whose hypotenuse is the square root of 15. Now that's not as helpful. And whose area is 3. So this one, we really are going to have to set up a system. So we have x and y, and this is square root of 15. So we know that x squared plus y squared equals the square root of 15 squared. So that just means that x squared plus y squared equals 15. And we know its area is 3. Well, that's a triangle. What's the formula for the area of a triangle?
Base.
Area equals half base and height. Well, in this case, our base and our height are x and y. And it tells us that area is 3. So our second equation would be 1/2 xy equals 3. So probably the best thing to do would be to, there's actually a couple ways you can do it. You can solve for one of these. We could go straight to Desmos and make it do the work for us. So let's go ahead and go into Desmos and use Desmos as our tool here. Does anybody know what this first equation is going to give us? It's not a function. Anybody familiar with that? Okay, So let's take these off and let's put our new ones in. So we have x squared plus y squared equals 15. What is that? It's a circle. All right, and the other one was 1/2 x, whoops, the x is not out there, xy equals 3.
Another circle.
Okay, so do we see the solutions? Okay, now I see 1, 2, 3, 4 intersections. Well, I made them go away. Are all of those solutions? No. Because these are lengths of the sides of a triangle. So, which quadrant do my extraneous solutions lie in?
The bottom.
Is it
3.
quadrant 1,
3.
2, 3, or 4?
3.
3. Quadrant 3. Those are extraneous solutions. What does the word extraneous mean?
A lot.
Extraneous is a solution that you find algebraically that is not a solution to the problem. It's extra. It's extraneous. It's an algebraic solution that is not a valid solution. So in this case, we have 2 of them right there. So these are the ones that work. Now, what do you notice about the x and y's?
They're crazy.
They really just swap, right? So the lengths of the sides of the triangle, there's really only one. One of the sides is 1.732 and the other side is 3.464. They're the same. All right, so let's take that and be thankful for our technology because that made that problem a lot easier. It went away. Oh well.
Wait, Miss Willoughby, how do you know which one's extraneous?
How do you know it's extraneous?
Yeah.
She get a new chair.
The chairs were moved around because of finals. So the desks are not in the same position they were in last time. What's he doing? Maybe he's going nuts.
Yeah.
All right, so there's our solution to this one. Okay, let's go ahead and flip it over to the back. And let's take a look at the ones that I want you to try for homework. Now, these are pure algebraic problems. So, if you have your calculators, you can plug them in Y1 and Y2. That's the only way you could do it on an assessment. But I'm going to let everybody go get their phones so that if you'd like to do it on Desmos, you can do it that way also. So the solution is the intersection. Now be careful for extraneous solutions.
Miss Willoughby,
Yes.
mine says invalid.
All right. Let me see what it's mad about. You got your plots turned on. You can turn those plots off. It'll be a happier calculator. There you go.
Just sitting down.
So like this was
Yep, there's your intersection. Okay. Good. Good.
You can't be like guys.
I need
Bring it
it.
over and pressing enter, but it's not doing it.
5.
Okay.
and then just
So Miss Willoughby, you said I could, if I return that, I could use your like stuff for testing and then use Desmos for homework and stuff. Would that work? Or?
Either that or you could check out a calculator to keep for the rest of the year.
Okay. And how much is that?
To check it out?
Or
Free.
free? Oh wow.
Yeah.
Okay. And I'll just have my
Yeah. Yeah.
keep up with class.
Hey, you can
I would use Desmos. Desmos is very nice. You can either use your calculator or you can use Desmos.
And you said there's an app for Desmos?
There is a Desmos app. We should be texting that. We should be Desmosing or. That's right. Make that a good
Are we still recording?
Desmosing.
Are we still recording?
We are recording.
Are you just saying that? Despacito.